Hey, welcome back to linear equations and proportion-wise equations. Today I'm going to show you how to work with several variables. Before we worked out how to work simple linear equation with one variable, and we also considered fractional equations. We have proportion-like equation or basically fractions. And fractional part might have variable. And the last example that we considered was that two fractions both have unknown variables in the bottom part, okay, in denominator. So that's why the main idea that allows you quickly operate with variables and quickly try to find solution is simply crisscross multiplication that you used to resolve proportions. I just grab this method and apply it here. So right now we're gonna go to equations with several variables. The best example is below here. Let's say we have 5x minus 1 equals to 7 minus 2x. So as you can see here, we have several variables, but I mean, in terms of unknowns, it's still a single one, but we have them in different parts of the equation. So it means that x is the single unknown, but technically you have several variables. For example, here 5x, and here on the right side 2x with negative sign. How to cope with this sort of equations? First of all, you need to expand the brackets. So first of all, try to expand and collect then similar terms, or what is called like terms, in one part, and numbers collect in the other part. So what I mean by saying that, first of all, let's see how expanding works here. It's just normal expanding. For example, here you just take 5 and multiply by each part or each term within the brackets. So you'll get 5x minus 5. I think you need to be familiar with that. And on the right side, we do nothing because they are not similar terms, or they're not like terms. So what to do next? We just keep the equality sign and transfer negative 2x to the left side because we want to collect similar or like terms on one side. For example, technically I see that it's better to collect in the left side. What if you transfer negative 5, that's a number, and you combine with 7? So you don't forget about swapping the signs. Before it was negative, swap to positive. If it's vice versa, swap to negative then. So right, we've got variables on one side, and this is technically it's one variable x. So while numbers we have on the right side. Let's simplify then. 7x together equals to 12. Alright, in order to find x, you just simply need to divide 12 by 7, and that will be your answer. So technically you understand that u works in the same manner as if there was only one variable, except for you have a little extension. You need to expand brackets and then simplify. So let's do probably a bit more complicated with fractions now. So let's see what we can do with fractions. What if we have something like that? X over 3 minus 1 minus, say, x over 6 equals to negative 4. Okay. So you see that now the variables in one side. So technically it's again one single variable, but they are separated. So what to do in this case? You see that this sort of fractional linear equations, okay? And what to do in this case? What do you need to apply? Which method? You cannot apply proportion here because right now you don't have like one fraction equal to another fraction. So there are two ways how to resolve this problem. The first way, and it seems to me the easiest way, you just need to multiply both sides by LCM of denominators. Sometimes it's called LCD. So LCM, the lowest common multiple for denominators. By denominators, I mean those fractions. Because you want basically to combine this fraction with what you have here. Okay, so in this case, what do you need to do? You need to multiply by LCM or by LCD, the lowest common denominator. So in this case, 3 and 6, LCM, that stays for it, it's 6. So this is the lowest number that is divisible by 3 and by 6. And this is the lowest possible. So of course you can take like 12, for example. You can divide by 3 and by 6. You can take 24, for example. But this is not the lowest. If you don't take the lowest, you'll just exaggerate your numbers, and instead of like smaller numbers, you will operate with greater numbers. So that's why LCM is the best idea here. You just need to multiply by 6 both parts. In this case, we multiply by 6 in order to cancel our fractions, and what we'll have. So from the first one, we'll get like 6x over 3 minus 6 times 1 minus x in over 6. And on the right side, because we multiply in both parts, we'll get negative 24 because of multiplication. So you see the possible outcome that 6 and 6 can be cancelled, 6 and 3 also can be cancelled, leaving you as 2. And you'll get finally 2x minus, be careful, minus before the fraction, so we're still using the brackets in order to properly expand on the next step. So let's see what we have. 2x minus, then we expand it as if here is negative 1. I mean, instead of just minus, we consider as minus 1 times what you have here in the brackets. So it means you need to times by 1 minus x. And technically, you just put a minus just before each term. When you have minus and minus, it will be positive sign, so plus. In order to distribute, you just need to put minus before each term within the brackets. But there are no brackets anymore. So you get minus 1 and plus x because you swap the sign. Two negatives during multiplication or during division will give you positive sign. Okay, that's equal to negative 24. So what we have the following. Similar terms here, 3x, while minus 1 can be transferred to the right side, and you'll get negative 24 plus 1. So finally, you'll get negative 23 n over 3. That's your final result. So one more time to recap. So what we're supposed to do. In this case, we can work like with fractions in proportions. So that's why, first of all, we need to come to linear equation without fractions, without the bottom parts. So that's why we decide to multiply by the lowest common denominator. If you have 3 and 6, so it will be 6. That's the primary way how to cope with that one. However, if you have normal fractional equation like this, let's say x minus 2 equals -1. So in this case, you can work as in the previous videos. So I explained you that you can work like with the proportion. So you can multiply crisscross. So that's why instead of 1, you can consider as a fraction 1/1. And in this case, you just need to take the bottom part, multiply crisscross, and that's it. So we'll get 3x plus 1 equals to. Many students ask me a question about, for example, this minus, does it refer to the top or to the bottom? So my answer, it doesn't matter. It can be referred to the top as well as to the bottom. But you need to decide. For example, if it's referred to the top, so your bottom part is positive. Or you can also write as positive top but negative bottom. Or you can write as it's reading here, 1/1. It means that just the whole fraction, just a negative number. In both cases, you'll have -1, right? Of course. And in both cases, you'll have negative number anyway. So that's why, because for me, it's better to refer to always to the top, and I consider that's the most appropriate. There are like sort of cases when you can put minus to the bottom part, but it depends on the case. I cannot say exactly right now because it's not right time, but when we'll have sort of this example where it's like significant or probably convenient, more convenient to put a minus down. So I will show you and put a stress in it. So right now what we're doing, we're multiplying -1 simply by x minus 2. So we write in x minus 2 multiply by -1, but I don't write -1. I just put a minus before the brackets, because multiplication by 1 always gives you a number or like your previous expression. So that's why I just often used minus instead of -1 times. Okay, so here what we're gonna do, we can write 3x plus 1 and then we expand the bracket. So 1 minus distributed to each part, each term within the brackets. So we'll get 2 minus x. I just swapped them because I first expanded here and I multiply minus by -2, I'll get +2 and minus x. So of course I could write like minus x plus 2, but you know, when you have enough experience, you can do as I'm doing right now. So next step is just to collect similar terms. Similar terms, we have x and we transfer it to the left side. This negative x will get 3x plus x equals to, then we take a number, +1, we transfer, we'll get -1 instead. So we get 4x equals 1 and x is just 1/4. So all 1/4. That's the final result. So one more time, how to recap. Here we just use our previous method that works well when you have single fraction on the left side and single fraction on the right side. So however, there might be more complicated examples that you can use the same approach as we used in the last example here. So and they lead to quadratic expression. For example, I can give you right now, but this topic will be referred to quadratic. I just give you, for example, x minus 1. Let's say it will be equal to x minus 1 over, let's say, 2x plus 1. So you see that two fractions basically represent the variables, because the top is the variable, the bottom is the variable, and expressions contain variable everywhere. So, but however, I will apply the same approach and just crisscross multiply them. I just show you for just how the method will be applied here, so that you understand that this method will have a little extension and you can apply even for quadratic. So finally it will lead to quadratic expression, and in GCSE there are lots of questions in this stuff related to quadratic expression after simplification, so after simplifying. Here you'll have x minus 1 times x minus 1. Alright, and after expanding, you understand that you will have quadratic expression. So that's why I'll do it quick. So 2x squared plus 5x and plus 2 equals, here I apply the formula, you know, a minus b squared. I apply this formula, it will give me x squared minus 2x, so plus 1. And then if I simplify that and try to arrive to a standard form like this, equals 0, in order to solve that, this is standard quadratic expression or equation, in this case because it equals to 0. So I just collect all terms in one side. In this case, approach is a bit different because you need to set up this structure. This is not like with linear ones. So what I'm doing, I transfer all variables and simplifying simultaneously. So I'll do it quick just to show you that we can arrive to this structure. So don't take this as at this stage, because in this video actually I show you the basics about linear equations. Right now just I show you the best way how to resolve those type of fractions. If someone just interested, just go to my next videos where you can see that. It will be topic dedicated to quadratic expression and equations, and also we'll consider inequalities there. So but for now you just understand how to apply the method of proportions where you meet fractions. Okay, that's the main idea. So probably we consider the last example here, and that will be the end point, at least at this stage. For example, let's see, we have the following equation over 6 equals to, let's say, x plus 4, let's say, over 12. So what are you gonna do? The method is pretty straightforward again. You're looking for LCM or LCD, so LCM of denominators, I highlighted them with yellow, or LCD, the lowest common denominators. Obviously it's 12. For those who are not able to determine LCM, how like I do it quick, so I can show you. So for example, you have 3, 6 and 12, those numbers. Just remember, there might be prime numbers, there might be compound numbers. So prime numbers is a number starting from 2, which is divisible by itself and by 1 only. So for example, 2, 3, 5, 7, and so on. So basically, they're numbers which are divisible only by itself and by 1. 1 actually, it looks like prime numbers because, yeah, you can see that it's divisible by 1 by itself and by 1. So, but there is no matter, because primes or prime numbers are designed in order to complete a compound numbers. So no matter whether you multiply by 1, it doesn't give you any effect. So that's why it was erased. It was eliminated from prime numbers and never included since again. So, all right. In our case, we have 3 only as a prime number. So how to find LCM, and by the way, I'll show you how to find HCF, the highest common factor. All right, let's do a little recap. What we want to say that each compound number is the prime product, right? The product of prime numbers. For example, 3 is 3 times 1, but because 1 is not prime number, we just will left with 1. So 3 is just 3, it's a prime. So however, 6 can be presented as 2 multiplying by 3. What about 12? So you can say that 12 is 2 multiplied by 6, but 6 is also 2 multiplied by 3. So that's why on the right side of this line, of this vertical line, I collect all prime factors of each number. So basically, from here, I can say that, first of all, the highest common factor. A couple of words about what it is. So the highest common factor is the highest common number out of all primes. So we decompose 3 by just 3, 6, 2 and 3, and 12 is 2 by 2, it's 4 by 3, you'll get 12. So that's why HCF is the highest common, means it should be common for each number that you want to take and the factor. So obviously this 3, and this 3 is HCF. So HCF is only 3. Because if you think that 2 is also, because it's here and here, yeah, I agree, between 6 and 12 it's common, but what about 3? 3 doesn't have 2 as a factor, so that's why 2 is not common for all triple. So that's why it's only for 2, but it's, so you don't count like this. So you need to find common between all three, from all three numbers. Okay, what about LCD? Because our primary goal is to find LCD according to the method. I want to finalize that quick. So about LCD, the lowest common denominator, or in this case just LCM, because in this case they don't look like denominators. All right, so how to find LCM? You just need to take only numbers. So you need to include in LCM the product of numbers, unique numbers, and if they're repeating, you just take it into account only one time. For example, let's say 3, 3, and 3 here, it's a repeating number. So that's why you include only one time. However, for example, this one, I put the blue. So, for example, 2, it's sort of unique because you can barely find 2 here. But it's also here. So that's why you don't include 2 twice. It just includes one time 2. So you include 3, you include 2, but because it's repeating twice, you include only one time. And what's left? So I put it, let's say, green one, and put it as a circle. So this is unique, right? Because only 12 contains this second 2. So that's why the last 2 will go from green. Okay, so it means this 2 is from there, this 3 is from this triple, but you don't need to repeat it, and 2 here you take just one time, it's from there. I put it, say, blue lines in order to differ them. So 2 from here and from here, but you take into account just one time. All right, so what we've got that LCM is 3 by 2, 6, and by 2 is 12. So by definition, what does mean LCM? One more time. LCM is the number that's divisible by each of your numbers. It means that your LCM should be divisible by 3, by 6, and by 12. And because it's lowest, it means that it needs to be the lowest possible number. 24 is also divisible, yes, as we noticed before, by 3, by 6, and by 12. But it's not the lowest. So, and this is exactly the way how you can find easily. So in order to apply this in GCSE questions, I saw a couple of that, like find LCM, find HCF. So no problem, just represent each number as the product of prime numbers, and hence you can find LCM. All right, so yeah, we actually we've deviated a little bit from the mainstream, from the main topic. So however, it will be a useful skill for you guys. So we found that LCM is 12. So what we're gonna do, I can say that first of all we need to transfer it. So LCM is not 1, but actually something else. It's 12. Okay, yeah, let's do it. All right, we found that LCM or LCD is 12, and that's why we need to multiply by 12 all two parts, the left hand side and the right hand side part of the equation. So that's why we're just multiplying by 12, and look what will happen. I can do it mentally. If we multiply by 12 here, so 12 on the top and 3 on the bottom will be cancelled. So you'll be left with 4 on the top, okay? So next one, 12 by x minus 2 over 6. So 12 and 6 will be cancelled, and you'll be left with 2 multiplied by x minus 2. And on the right side, 12 will be completely cancelled. So you'll be left with x plus 4. So we arrived to standard linear equation with several unknowns here, here, and here. So your goal is first to expand brackets, simplify, and collect all variables, all unknowns on one side. So as you can see, you can collect them. So for x and 2x, 6x minus x, you'll get 5x. You see how it works fast if you do like most steps mentally. So 4 and minus 4 will be cancelled. There is no need to cope with that. You'll get 4 on the right side. So final answer is x equals 4 or 5. Let's assume that on exams you found this number as the final answer, but you are not sure because on the way you might have like miscalculations, you might do incorrect transfer, you for example forgot to change the sign when you transfer. So what to do, how to check whether your number is actually a solution? So right, I didn't tell you, but now I'm gonna give you a little secret. You can do the check, and you know in maths there are lots of checks. First is just the sense, right? That I mean, for example, you see the line. I give you an example for lines. So for example, you were looking for the gradient for the line, but you found that the gradient in the equation is mx plus c. So m is, let's say, positive and a equals to 2, for example. But you obviously see that the line is sloping down. So, for example, you were given the line, or you were given like 2 points that it goes through. Obviously, this is just checked by the sense. You understand that the gradient should be negative. And I would advise you to do it in the very beginning before you start solving. So just have a look at the graph, or if you're given points, you just imaginary put the line that goes through, and you estimate that the gradient is just negative, right? If you found that the gradient is positive, obviously on the way you miscalculate something, or you made several mistakes that leads to a wrong answer, incorrect. So that's why do check. So check will help you somehow to understand and to have, to redo your exercise, redo your problem one more time. For example, let's see how we can do it in our case. Let's say we found x equals 4 over 5. If it's from calculator section, so it's better to calculate, convert to decimal. 4 over 5 is just 0.8. I multiply by 2. Both parts, the top and the bottom. That's how I arrive to the decimal. I'll get 8 over 10, or 0.8. That would exactly I have. And you need to use the very initial equation. You don't need to use, for example, this simplified. No, it doesn't work because you might have mistake, for example, on the second iteration. on the second step. So that's why only what you actually were given in the very beginning, in the original equation. So how you can put it and check yourself, just simply use a calculator and put the value x equals 0.8. So what it gives to you, what solution should give you? It should give you right equality. For example, 0 equals 0, or like another number, like a something equals to a. So you need to arrive to right equality instead of equation, because once you found your solution, you don't have variables anymore. So that's why you'll get sort of right equality. You should get this. All right, and just take your calculators and try to put, whenever x stays everywhere, I circle all x's here. So you put 0.8 instead of all x's. So precisely calculate, just if your calculator allows you to do like all calculations even with fractions in a line, so just do it in a line. Like first calculate the left hand side of the equation and right hand side. So you should arrive to a equals a. For example, I'll just put it only here to show you how it works, and hopefully I'll get the left hand side the same. So x plus 4, so I'll get 4.8 over 12. And that means now I need to divide using calculator or just, canceling. So I don't know, let's try to cancel because I know 48 and over 120, that's my way I'm doing this. You know that 48 and 12 will be cancelled, leaving you with 4 on top. And instead of 0, of course, you'll have 10. So you'll get 0.4. So you can redo by calculating and check. My calculation should be 0.4. So that's why on the left hand side you should get also 0.4. If you get another figure, obviously we made a mistake, but hopefully I'm sure that it's not. All right, so that was the topic, completely covering equations. And in the next video, actually it is supposed to be here about word problems and how to create and form equations, but I think I'll create the separate video for that. So don't worry, you'll get it soon, especially those students who actually demanded this video. So I gave some I was given some comments to create video dedicated to word problems and probably to show how it works in distance travel time. So for sure, guys, I'll do it, but I need some time for that. All right, so thanks for watching. Don't forget to subscribe. Just press the bell button to be notified about latest updates. And so just keep training. Don't forget about the training. That's essential. Thanks and see you.